Today we're going to take a look at writing a quadratic equation into vertex form. So here we have a quadratic function. It's written in standard form, ax squared plus bx plus c, and we're going to write it in vertex form, specifically so we can look at the transformations that have been done to that function, and specifically the vertex. So the first thing I always do is remember this f of x. Whenever you see that, that's just a y. So it's a little bit easier to deal with for me as a y. So I'll change that over. Now, all we're going to be doing here is completing the square. And anytime we complete the square, we want a couple of things just to make our lives easier. One of the biggest things is we want this x squared term to be by itself with no coefficient. And it's going to help us out a lot if we just get rid of the c for a little bit. So I'm going to start by just getting this equation ready to complete the square. So I'll subtract 11 from both sides. Make it a little bit nicer to look at. From here, I'm going to divide by 2 to get rid of that coefficient. And one thing we have to remember here is we can't just divide by 2 in the terms we want to divide by 2. It has to be every single term. So there, our new equation. I'm going to leave this over here alone. Y minus 11 divided by 2 equals x squared plus 4x. So that was all just to get it ready. This right here is the form we want to have ready when we use completing the square. It's going to make our lives a lot easier. So the next step is going to be to actually complete the square. And to complete the square, we're always looking at this b term right here. And the nice way to remember what to add to both sides is that we're going to take that b term divided by 2 and square it. So for this one, we're going to add 4 divided by 2 and square that. So 4 divided by 2 is 2, and 2 squared is 4. So we're going to add 4 to both sides. Over here, I'm not even going to worry about common denominators or anything, and you'll see why at the end. Our next step in this is the whole reason we're doing this. We've made a perfect square trinomial over here, and I can rewrite that as a square. And so I'm going to have x plus 2 squared, because x plus 2 squared would give me x squared plus 4x plus 4. I'm just factoring it, but I know that's a perfect square because we completed the square. On the other side, nothing at all has changed. I just factored the right-hand side. Finally, to get this back into function notation like I wanted at the original, I'm going to go ahead and just solve for y. So I'm going to take all those steps that I did to get the x squared alone, and I'm going to go back and undo them now. So the first thing I'm going to do is subtract 4 from both sides. And so I'll end up with y minus 11 over 2 equals x plus 2 squared minus 4. From there, next step would be to multiply by 2. And so the biggest thing to remember here is when we multiply, just like when we divide, we're multiplying everything by 2. That includes this minus 4. And then I'm going to have to add 11 to both sides to get this back to y equals. So plus 11 would make that plus 3. And of course, since we want this in function notation now, we can rewrite it as f of x equals 2 times x plus 2 squared plus 3. Now in this form, we've got some nice things that we can look at without even having to do any work. In this form, with vertex form, I can tell right off the bat what the vertex is by looking at these two numbers here. This number would tell me that the parent function x squared has been shifted, this time since it's plus 2, to the left 2 units. And this one's been shifted up 3 units. So that's going to take my vertex from 0, 0 to negative 3, or negative 2, 3. So that would be my vertex. So in vertex form, we get that vertex for free. Other things that I can do in this form that I can't do as easily in the standard form is finding the x-intercepts, or the zeros of the function. So if I have an equation in standard form and I want to find the zeros, remember we're replacing the y value with 0. And if you recall, Algebra 1 says if I have an equation like this, a quadratic equation, and I want to solve that, I have some options. I can factor it, I can complete the square, or I can use the quadratic formula. This one's not going to factor, so I'm going to have to use the quadratic formula or complete the square. But the nice thing is, we just completed the square. So if we wanted to find the zeros of an equation like this, all we'd have to do is replace that f of x with 0, And since we've already completed the square, we can just solve an equation. Now in this case, since I have plus 3, I'm going to start by subtracting 3 from both sides. And then taking the square root, we end up with a little bit of a problem here, at least as far as we're concerned right now, in that I can't really take that square root. And so since I can't take that square root, this is a negative number, we're in a little bit of trouble. We don't have any zeros on this function, but we'll get there later. So it's nice to have it in this form for a couple of reasons. The big one's the vertex. Also, it's a little bit easier to solve for the x-intercepts. If you're asked to find the y-intercept, however, standard form is the way to go, because the y-intercept is where x is 0, and so if I plug in 0 for x, well, clearly those two terms are going to cancel out, and 11 is my y-intercept. So y-intercept out of standard form is really nice, but for finding the vertex and the x-intercepts, which this one doesn't have, this form is a nice way to go.